Okay, so this is the fifth video in the series of name reactions. So today we are going to discuss about Alder-Ene reaction. So this is a question for you. I want you to react this particular alkene with this alkene in presence of heat or Lewis acid like zinc chloride. So what is the product you are expecting? So this is what we call the Alder-Ene reaction. Basically, it's a Diels-Alder type of reaction where we have a concerted mechanism. What I mean is, in a concerted mechanism, in a single step, you are going to form the product. So let me draw the mechanism for this reaction. So this is my one of the alkene, and this is my another alkene. And we are heating it up in presence of zinc chloride. So mechanistically, you need to look out for the carbon adjacent to alkene. So this carbon is attached to hydrogen. So this alkene will take this hydrogen, this CH bond will break and will form double bond here. This double bond will migrate and get attached to this carbon. So this is what we call the concerted mechanism, a sort of arrow pushing mechanism. So let me number them. This carbon is 1, 2, 3, 4, and this carbon is 5. So the product will be, so we have a double bond between 1 and 2. 2 is attached to 3. 3 is attached to 4. And 4 is now singly bonded with 5th carbon. And the hydrogen which was earlier attached to 1 carbon is now attached to 5th carbon. So this is the product for this reaction. And this is the mechanism for it. So now let's go ahead and solve some practice problems based on Alder-Ene reaction. Okay, so here is the first question. I have this particular alkene and I am reacting it with formaldehyde. We are heating this reaction for 1 hour. So what is the product? So let me draw the mechanism. So this is my alkene and this is my formaldehyde. Here we have a hydrogen. So this is my carbon adjacent to alkene and this carbon is attached to hydrogen. So this double bond will now act as an alkene. This will grab this proton. This bond will migrate here and this bond will get attached here. So let's number them. 1, 2, 3, 4 and this oxygen is 5. So the product will be 1 and 2 doubly bonded. This 2 is attached to R group. 2 is attached to 3 which has R1. 3 is now attached to 4 and 4 is singly bonded with 5th which is now having OH group. So this oxygen took this hydrogen and become OH. So this is my third, this 4 is CH2 and this is my 5. So this is the product for this reaction. Okay, here's the second question. So we have this as one of the reagent and we are reacting it with this alkene in presence of DCM at room temperature. So what is the product? So this is my carbon next to an alkene and this has one hydrogen. So this double bond will take this proton, this CH bond will form double bond here and this double bond will get attached to this center. So the product will be PH singly bonded NHOTS, TOS, and this bond is bonded with, let me number them. So this is my 1, 2, 3, 4 and 5. So this is my 1, 2 is bonded to 3, 3 is bonded to 4, 4 is bonded to 5 with double bond, and 4 is containing one pH group as well. So this is my product for this reaction. Let me give you one more example. Let's say I am reacting this ketone. Let me keep aldehyde here. So we have an aldehyde and we have a ketone in one molecule, and this is my alkene. I am reacting this in presence of a nickel catalyst, and we are heating it up. So what is the product? So one of them is going to react. Either aldehyde will react or the ketone, and we know that aldehyde is more reactive than ketone. So aldehyde is going to react. We have a hydrogen here. So this double bond will take this proton. This CH bond will form double bond here, and this double bond will get attached to this center. Okay, so let me number them: 1, 2, 3, 4, 5. So the product will be this O becomes OH, and that is my 1. We have 2 here. 2 is bonded to 3. 3 is singly bonded with 4. 4 is doubly bonded with 5, and this 4 also contains R1. So this is the product for this reaction, and we have generated a chiral center at this position. Okay, here's another question. So this time I have a ester and an aldehyde in one single molecule, and I'm reacting it with this particular alkene. We are using toluene as a solvent at room temperature. So feel free to pause the video and find out the product. Okay, so this is my carbon adjacent to alkene having hydrogen, and aldehyde is more reactive than ester, so aldehyde will take part in the reaction. This double bond will take this proton. This bond will form double bond here, and this bond will attack here. So the product will be, so this is 1, 2, 3, 4, and 5. So the product will be this O becomes OH. This is 1, 2, 2 is bonded to 3, 3 is bonded to 4, which has R2, and 4 is doubly bonded with 5, which has R1. So this is the product for this reaction. Okay, here's the another question. So this is my alkene, and I'm reacting it with this molecule in presence of DCE as a solvent. DCE is dichloroethane. So what is the product? So we have a hydrogen here. This is a carbon next to alkene. We have aldehyde and ester. Aldehyde is more reactive, so this will take this proton. This will form double bond here, and this bond will get attached to this carbon. So let me number them: 1, 2, 3, 4, and this oxygen is 5. So the product will be so we have a double bond between 1 and 2. 2 is now singly bonded with 3. 3 has this R group. 3 is bonded to 4. 4 is bonded to 5th OH. And this 4 also contains CO2 ET. So this is the product for this reaction. And here we have generated 2 chiral centers, carbon 3 and 4. Okay, here is the another question. So this time I have two double bond in a single molecule. I am heating it up in presence of xylene as a solvent for 4 days. So what is the product? Feel free to pause the video and try this reaction. Let me give you the hint that we are going to form a ring system here. Okay. So we have a hydrogen here and we have a double bond here, right? So this will form double bond here. This will attack at this center and this double bond will take this proton. So what is the product? So we cyclized at this center, correct? So we have a 1, 2, 3, 4, 5, 5-membered ring. So let me number them. This is my 1, 2, 3, 4 and 5. 3 is nitrogen, which is attached to this CpH3 group. This is my 4, 5, this is 2 and 1. So 5 is now attached to a methyl group. 1 is now attached to this particular system. So this is my alkene which we recently generated here. And this is the product for this reaction. Let me give you one more example. So one of the reagent is this acyclic acetal, and we are reacting this with this alkene in presence of Lewis acid. So what is the product? So I have already discussed in my previous video in the series of protection and deprotection that in presence of Lewis acid, the acyclic acetal or ketal will form aldehyde or ketone. So make sure you watch that video so you will be able to understand that how this converts into a aldehyde in presence of Lewis acid. So we have a Lewis acid mediated deprotection and we form aldehyde. Now this reacts with this particular alkene and now the things are straightforward. So this will take this proton, this will form double bond here and this will attack here. So the product will be so let me number them 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. So this is the product for this reaction. So the key step was you should know that you are able to convert your acyclic acetal ketal into aldehyde in presence of Lewis acid, and then you will be able to predict the product. Okay, so here is the another question. This time I have this particular group and we are reacting it with this particular alkene. In presence of ferrous chloride 40 degrees Celsius for 6 hours. So what is the product? So we are reacting this molecule with alkene in presence of ferrous chloride 40 degrees Celsius for 6 hours. So feel free to pause the video and find out the product. Okay. So we have this molecule and we have a alkene. So this carbon is having one hydrogen. So this bond will take this hydrogen, this will form double bond here, and this will get attached to nitrogen. So the product will be so here we have a double bond, this will remain the same, and now this is bonded with NH and AR group. OH has left now in form of water, so the byproduct is water here. So this is the product for this reaction. Okay, here is the another question. I have this alkene and I'm reacting it with TMSCl in presence of TCM as a solvent. So what is the product? Well, I have already discussed this in protection deprotection alcohol video. So TMSCl can be written as trimethylsilyl chloride. So once again, this bond will take this proton, this will form double bond here, and this double bond will form bond with silicon. So the product will be this one. Okay, so this bond takes the proton, this is forming double bond here, and this double bond forming bond with silicon. So once again a arrow pushing mechanism, and the byproduct is HCl. Okay, so here's the another question. So I am reacting this molecule with this molecule in presence of TBAF. TBAF is tetrabutyl ammonium fluoride. So what is the product for this reaction? So we know that TBAF is going to give me F minus source, F minus anions, and this F minus has very strong affinity for silicon. So this will form bond with silicon. This bond will break and form triple bond here, and this bond is going to break. So OTF is a leaving group here, and we have generated this very reactive intermediate called benzene, which we will discuss in future videos when I will start the series of reactive intermediates. And we have this triple bond here, right? So now this time I have a hydrogen here, so this triple bond will take this proton, once again the arrow pushing mechanism, this will form double bond here, this is a carbon and this is a carbon, and this will form bond here, and we are going to form so now this triple bond is a double bond, this is bonded with this center. Okay, here we have a double bond, this is a carbon, we have a double bond which is attached to R1, right? Let me number them. So this is my A, B, C, D, E. So this is my A, B, C, D, E, and this is the product. Okay, so here's the another question. I am reacting these two molecules in presence of zinc chloride. So what is the product? So this is straightforward. We have hydrogen here. This bond will take this hydrogen. This will form double bond here, and this will get attached to this carbonyl system. So the product will be, now we have a double bond here, CH2, and we have OH here. So let me number them: 1, 2, 3, 4, and this oxygen is 5. So we have a double bond between 1 and 2. 2 is now singly bonded with 3. 3 is connected to 4, which has R and R1, and 4 is also connected to oxygen, 5th, and now this oxygen is taking this hydrogen, which is here. So this is the product for this reaction. Now this is the next question for you. Feel free to pause the video and try by yourself. So I'm reacting this molecule. It's a sort of intramolecular reaction where you have alkene and aldehyde in the same system. And when we have this kind of reaction, the ring is going to form. So we have a cyclohexane as a solvent, and we are keeping this reaction for room temperature at room temperature for 5 days. So what is the product? Feel free to pause the video and find out the product with the arrow pushing mechanism. Okay, so we have a hydrogen here, and now we are almost done. So this double bond will take this hydrogen, this will form double bond here, and this will get connected to this carbon. Okay, so let me see what is the ring system we have generated. So this double bond is getting attached here. So from here it is getting attached. So this is 1, 2, 3, 4, and a 5. So we have generated a 5-membered ring where 1 is getting connected to 5. So oxygen is 3. This is my 2. This is my 1. 4 is having R and R1. And this is my 5. Now 5 have the OH group. So 5 have one OH, and 1 contains this particular group. So this double bond is here, and this is the product for this reaction. So we have seen Alder-Ene reaction. We have solved 12 practice problems, and that's it for today. Thank you for watching.